This is the second in my series on cheap Chinese electronics kits, and in this episode we'll have a look at this kit. It is a YDCS transistor tester, so by the time we've made this, hopefully we'll have a working transistor tester. I'm doing these videos to try to figure out if these cheap kits are worth buying, and two aspects really. One is there going to be a final product that is worth the money that I paid, and secondly, I'm including the fun factor in assembling the kit, if it's frustrating or fun to make, and whether it's worth spending the money. Most of these I'll never use, but I want to just go through these and see if it's interesting or fun going through the assembly process. So I'm buying kits in two price bands. I'm looking at kits under £5 delivered and kits under £10 delivered. This is one of the under £10 delivered kits. I paid £9.95 for this delivered, and this is what turned up. It's in a jiffy bag, but this is what was inside. I haven't opened it yet. So we'll open it up, see what's in the kit, and then look at getting it assembled, and we'll go from there. So two bags. One's got this kind of a plastic enclosure that the tester goes in, so we'll have a look at that first. Just get the bag opened up. Very nicely packaged, by the way. It's like they've heat shrunk it. And we have the front and back and side parts of the case, all the mechanical fittings, very nicely cut, and looks like quite a comprehensive kit there, so that looks quite good. Let's look at the electronic components that come in the kit. So we have the display, there are some instructions. So if you recall, in the previous kit the instructions were Chinese, so let's have a look at these. Again, we've got the schematics, so that's quite useful. Nice board layout. Parts list is in English, and the instructions seem to be in Chinese and in English, so that's a bit of an improvement from the last kit. So the extra £5 seems to have got us some English instructions. Whether these are useful or not, it's hard to say. A lot of the time the translation from Chinese to English is not all that successful, but I will go through this and we'll try and assemble it as per the instructions, but most of the time it's fairly obvious how these go together, and it's just a case of slotting the parts into the board and seeing how it progresses. So it's not a bad board. The silk screen could be designed better. There's a lot of overlap on a lot of the text, but it is readable. And it has all the values on there, so some of the numbers seem a bit strange. So resistor 1.4, resistor 12, I'm assuming that should be resistor 14, but you know, there's resistor 14 down here, so resistor 1.4, that's a strange designation for a part. Some of the silk screen is actually across the component, but okay, it looks clear enough. So that's the board. Just get the rest opened up. So ZIF socket and the socket for the processor, badly packaged in nice static generating foam, so hopefully it will still work. And a bag containing a nice collection of resistors, capacitors, and other bits and pieces. So next thing to do is I'll start getting this assembled. As before, I won't go through fitting all the parts to the board. I'll just show you some key stages as I get to them. So I'll start by fitting the resistors and see how that goes. They do appear to be quite nicely identified, so they have gone to the trouble of printing values on here. So this says 680 ohms, 3K3. I will check them as I go to make sure that they are actually correct. Okay, so I'll get the resistors fitted to the board, and then we'll have a look at it and go from there. Okay, so that's all the resistors fitted. There does seem to be one spare resistor of each value. Turns out the instructions are just operational instructions how to use it once it's been assembled, so they're not much use in the actual assembly, but as I said, it's mostly fairly intuitive anyway. So I'll now get the capacitors installed, put the IC socket in, and then we'll have a quick look and go from there. Okay, so that's the capacitors and the socket fitted. So far the only negative thing I'd say about this is the holes in the PCB are much too big for the components. It's just a sign of a cheaply made board. In general, the larger the holes, the cheaper it is to make the board, so I'm assuming they've gone for larger drill sizes than they really should have done. I mean, it's not a big issue, it just uses far more solder than it should, but it is going together quite nicely. So we'll get on and fit the next parts, which are the crystal, the trimmer pot and the transistors. So we'll get those fitted and then have a look, and we can get on to the mechanical parts. Okay, I've got the transistors fitted, voltage reference and voltage regulator. I'm getting the impression with this board that whoever laid it out had bought a PCB layout program and didn't fully understand the concept of footprints and whatever, so a lot of footprints are actually wrong, but it still works. It's not been too complex. The only thing I've had to do is get out the multimeter to check the voltage regulator connections to make sure that's in the right way around, but other than that it's going together fairly well. The next thing I'm going to do is fit the mechanical components, the socket, the switch. I'm going to leave the LED out for now because that will need to be adjusted to suit the enclosure, however that happens to go together, but I'll fit the connector for the display as well. Doesn't really matter which way around these goes, but I generally put the socket on the PCB and the pin header on the display. I tend to prefer it that way, and it's less likely I'm going to short something out if I'm testing it further down the track. So I'll get these parts fitted, and then we'll see what's left to put on here and then get onto the case. Okay, so I've got the mechanical parts fitted to the board. We can fit the switch cap. Okay, now it does have a power adapter connector here, and also there's a battery connector. What I'm going to do for initial testing is use the bench supply, and that allows me to check for the supply current, that sort of thing as well. And for now we'll get the processor plugged in and power it up, see what happens. If it all works, then all well and good, we'll be able to assemble the case and have what I hope will be a fully working tester. I have realised what these down here are for. They're actually test connectors, so you press a component here to test it. So I'm not quite sure how well that would work, but we might give that a go. And as I say, I'll get the rest finished off and see if it works. Okay, so I've soldered in the connectors, switch, etc. I've fitted the processor. For anyone interested, I don't know if you can see this on the camera, but for anyone that's interested, it's an AT Mega 328P. I'll see all these sales here. I'm hoping it's programmed, and I've got this hooked up to the bench supply, which is set to 9 volts. I've just got the LED flopping about for now. I don't know if we'll need to align this with the case. And we've got some connections down here which I think are for tinkering with the code inside the AT processor if we ever want to. So I've also got the connector soldered onto the display, so we'll get that fitted. Okay, and we're ready to power it up. So I'll power this up. I believe it comes up in standby mode, so it probably won't do anything until we press the button, but I'll power it up. And pretty much no current being used whatsoever. It's showing 0 on the bench supply, probably drawing a few microamps. I'll try pressing the button and see if anything happens. Okay, well, something's happened. We're getting nothing on the display, but I suspect that's this control here is going to be the contrast control for the display. So we'll try adjusting that and see if anything appears. The LED's on, and looking at the schematic it seems like it's controlled from the processor, so chances are the processor is actually working. So nothing in that direction. Get it away, and we have something on the screen. It's telling us we've got a capacitor in there, which obviously we don't, but it's got no way of knowing that. So what I will do now is fit a device into the socket and see if it can test it. So I've got a small NPN device here. Obviously it's not happy being handled like this, which is presumably why they provide the case. So we'll pop this in. Okay, and I'll try pressing the button and see if it can figure out what it is. And it's come back with, it's an NPN transistor, base, so it's even got the connections correct, and that looks quite promising. So what I'll do now is get the case assembled and try and get this socket working a bit better. It's a bit difficult getting things in and out. That's a problem with these cheap sockets. And we'll get the LED soldered in place, and we'll go from there and see if it's actually any use whatsoever. The kit was okay to assemble. Wasn't particularly exciting, just a few components to solder in there, but it certainly wasn't too bad. And if it's just a cheap kit you're looking to play about with for a while, it seems to be worth the money so far. Also, some of the components might be useful for other things, and also because we have access to the program connections for the processor, it might be quite a good development board as well. So I'll get on with the case assembly and see if we end up with a useful piece of test equipment. Okay, that's the unit assembled. It went together reasonably easily. The case is a bit of a faff to assemble, but not too bad. And overall it all slotted together fairly easily. So last thing I'll do is to power it back up, make sure it still works, and we'll test a small selection of components. Just pick some random components here and we'll see what it makes of them, but hopefully it will be able to test them all successfully and give us some sensible results. It's not meant to be a high precision piece of test equipment, but it should enable us to do some basic testing on a few components. So we'll power it up. I did fit the internal battery connector and the switch on the side, but I'll run it from the bench supply here. And for anyone that's interested in this mode, it's drawing 11 microamps, and when we power it up it's drawing 16 milliamps, which is actually quite good considering how bright the backlight is. So we'll try a small selection of components. So we'll start off with a small bipolar transistor. This one's actually a PNP. Okay, so we'll try testing that. And it's come back with the right type of device, and the connections are in the right order. So that works. We'll try a larger device. see what it makes of this. And again, that's come back with the correct parameters, pins in the correct order. It's actually fairly fast as well. The commercial one I bought is much slower than this, but it could be it's carrying out more thorough testing. This would also be quite useful if you wanted to see how these devices work. You could also take the board out, put a scope on it, and see what it's actually doing when it's doing the testing. Okay, so we'll try fitting a capacitor. Okay, it's a bit slow, but it's come up with the correct value. It's a 220 microfarad capacitor, and it's saying it's 216.6, which is quite good. Gives us the ESR as well, and it's actually quite thorough in its testing. It's kind of useful in that term. It's not going to be massively accurate, but it's going to be somewhere close. And if you wanted to, you could of course do some more thorough testing and compare it against some calibrated reference equipment. Okay, I've got an inductor. Okay, which again, it's identified correctly as an inductor. It's roughly the correct value. It's a little bit out, but not too bad. But it is identifying the components successfully. Just try a few more. So I've got a 100k resistor. So we'll test that. And close enough. I've got a diode here. Which again is successfully identified. Comes up again with some very interesting characteristics and quite a lot of useful information. It's not just saying it's a diode, it's giving us the reverse current, forward voltage and the capacitance, as well as the fact it's identified it as a diode, which is okay. And finally, I'll run that again. A 100 nanofarad ceramic capacitor, which it has correctly identified. So overall, it's working very well. It does seem to be doing what it's supposed to. So the big question, is it worth the money I paid for it? Just under £10 delivered. And I would have to say that yes, it is. You can buy this type of tester ready assembled quite cheaply. But as I said, this is about the fun factor as well. And this was quite an interesting kit to assemble. I wouldn't say it was a particularly high quality kit, but it was fun to put together. And it's if you don't already have a component tester, it makes quite a nice addition to the workshop. On top of this, you have the added benefit with something like this that, as I said, you can use it as a type of development platform to create your own products with. You've got access to the programming port on the processor, and it's got a display and button, a few connections, so it'll be quite flexible for doing various types of testing on. And as I said, overall I would say it was worth the money.